All right.
Hello, everyone. Welcome to our session on using VS Code to build AI apps and agents. We're happy you decided to join us today. I'm Lori Fraley, and I'm a product manager at Microsoft focused on the Azure SDKs and the new Azure MCP server.
Hello, everyone. Morning. How's build so far? It's day 3. If you're not tired of hearing about AI agents yet, we're going to tell you more about it today. My name is Rong Lu, and I'm also a product manager on the same team with Lori. Let's get into the content. So we're going to be very brief to talk about how AI agents work. I promise we'll be brief. And then we're going to just dive into lots of demos. We have a lot of content to run through today. So we're going to start with building a local AI agent with MCP servers. And I'm sure you have heard about that many times in the last 2 days. And then we're going to take the next step, which is to scale the app, the AI agent, and deploy that into Azure. So there will be many Azure services involved in that second step. But we'll walk through everything together. And our goal is to stay in VS Code 100% of the time, as our title says. So you guys keep us honest. If we step outside of VS Code, you can raise your hand. And we'll see how many times that happens. And then we'll recap the content. So real quick, how AI agents work. At very high level, AI agents respond to user queries and perform tasks on users' behalf. Now, if we double-click into the agent box, really, at the core, it starts with these LLM models, generative AI models. Initially, we prompt these models to answer questions using their built-in knowledge, right? And that was like 2 years ago. Over time, our expectations are higher and higher, and we want them to do more things. So instead of suggesting a code snippet that I should use, just go ahead and edit files in my directory, and that's fine, right? We want the agent to do more things. And with that, the models need access to external tools. And when models are able to access either call external APIs or query databases or browse the web, the model is like getting superpowers. And when they do have those powers, they are so much more capable. They can do pretty amazing things, from creating a fully functional web app from scratch all by itself within minutes, to be your coding assistant like a Copilot that can do. So there's a lot models can do with these powered tools. But configuring each different tool with a model could require quite significant effort, because each tool exposes their interfaces differently. And that's where MCP, Model Context Protocol, comes into the picture. This is a unified interface. Think of it as USB port where you can plug and play any external devices. As long as these tools, whether it's an API or database or the web, is wrapped under an MCP's protocol that can be connected to this model pretty easily. So we'll see that in a little bit in our demos. So with that, let's go over the high-level diagrams for what we're going to show today, because there's a lot. As I mentioned earlier, we're going to start with building a local agent. We're going to use a model that will call 3 MCP servers. So instead of 1, we are going to use 3. One of them is going to access our file system. It's going to be a local file. And the other 2 are going to access the web to retrieve real-time information. And with all that, the model is going to synthesize the data and make smart decisions. After that, we're going to start taking pieces of our agent into the cloud. Throughout the process, we use the AI Foundry service. I'm sure you have seen a lot of that in the keynote in the last 2 days as well. And then we're going to deploy MCP server into another service called Azure Containers App Service. And as we move that file system, MCP, into the cloud, instead of a single file, we're going to move the file into a SQLite database. So everything will be up running in the cloud. So that's a very high level of what we're going to cover. So let's dive into 5 minutes into the session. Let's dive into the first demo, which is to build MCP server locally.
Yeah, thanks, Rong. So to get us started, we're going to have a local MCP server, and we're going to leverage GitHub Copilot and VS Code to interact with this MCP server. We're going to take advantage of something called TypeSpec to get our MCP server up and going as well. So if you hadn't heard a ton about MCP servers over the last few days, you have different hosts, such as Visual Studio Code, and then different clients, such as GitHub Copilot, which is what we'll show today. And then the servers are what are providing different capabilities through the different interfaces. So in our example, VS Code with GitHub Copilot will call all the tools and extensions that are already built into VS Code, but then leverage MCP servers for additional capabilities. MCP servers can both run locally on the machine, which is where we're going to start, but they can also run in the cloud as well, which is where we'll be at the end of this hour. And then when they're in the cloud, they use something called SSE, or server sent events, to send messages back and forth. And so we're going to leverage Azure Container Apps for our remote servers, but you can also leverage Azure Functions or App Service, and you can leverage other Microsoft products such as API Center and APIM to help manage these as well. Now, I mentioned that we're going to use TypeSpec to run our MCP server. TypeSpec is an open source language and tooling that Microsoft has created and the community supports that helps you create an API easily readable for your service. You write it in a concise, human-readable format. If you're familiar with OpenAPI and trying to write those API specifications, this is a much higher level, simpler language. And then you can generate all the artifacts you need for your API definition, whether it is that OpenAPI schema, a JSON schema, or protocol buffers. You can generate server-side code skeletons, which you'll see us do today, client libraries, documentation, and TypeSpec even has a custom emitter framework if you want to do even more. And today, because we're getting really meta and we want to help you hit everything on your bingo card, we're going to use an MCP server to generate our MCP server. So let's get into the first demo. So I've got VS Code up here, and I've got GitHub Copilot open in agent mode. And we'll go ahead and look at what tools are available to us. So we have GitHub Copilot Chat, which is installed by default. And then I've already pre-installed the TypeSpec MCP server that's going to help us get going. And so I'm going to ask Copilot to create and build a new TypeSpec MCP server in this workspace. Now, GitHub Copilot always warns you when you're using a tool that wants to make sure you really understand what it's doing, so we'll go ahead and continue. And it's initializing a new project in this workspace. In a minute, it will generate the TypeSpec file, which is under the .tsp extension, and I'll show it to you. And then it will build our project. It will generate our TypeScript code for our MCP server and get it all configured and running. So if we look at our TypeSpec file, we're leveraging MCP, and we have a simple to-do server that's going to be our MCP server today. So the items in the to-do server will have an identifier that's just an integer, a string, which is the thing we want to do, and then a status of whether or not it's still to be done or already completed. And then we have 3 tools in our MCP server to start. Let me hit continue while we talk. We're going to be able to add to-dos, list to-dos, and delete to-dos. And as part of the demo today, we're going to actually generate some additional tools for this server as well. So this will have generated an mcp.json server that specifies our new server, and I'll go ahead and get it started. And if I get a new chat going and pop up our tools, we now have our local TypeSpec MCP server with our 3 tools available. So in Copilot, I can just say list to-dos, and this comes with some data already in the local file system. Has 3 things it would like us to accomplish. It would like us to learn TypeSpec, learn MCP, and learn about the TypeSpec MCP agent. And so I can say add a to-do, which is to add a new tool to the MCP server. And now our GitHub Copilot's calling the MCP server. It's added a new item, which we should see in the list. So now we have 4 things in our to-do. Now I mentioned we were going to add a new tool, and we're going to let Copilot help us vibe code this. So add a new tool to update to-dos. So in a minute, we're going to see it's updating our TSP file to add this new tool called update to-do. And then let me tell it to build the MCP server. So now it's going to try to build this, and it's going to figure out we have no implementation for this tool. And oh, I've made it really mad. I had not swapped to the type spec file.
Vibe coding on stage.
Yeah, oh, I also didn't say keep. That would help as well, right? Build our type spec MCP server project. There, how about we add a different tool? I've never tried this before. Let's always try something new on stage for the first time. So we're going to reverse the to-dos in our list. And it still wants to run the npm command rather than my build tool. And this is going to fail. Or not. See, there we go. Now it's found an error. Now it's going to go try and fix the code. So it's checking all the files in our project. It's thinking about what it wants to do so it can help us code this. So if we go over to the type spec file, it's now created implementations for both the update and the reverse to-dos. Now it wants to build again. All right, so let's go back to the mcp.json. We're going to restart the server, and it should go from 3 tools to 5 tools because we now have implementations for our new tools. So, new chat. Let's see what's in our to-do list. And now we're going to update learn type spec to use type spec. And let me say update to do. And now we can list our to-dos. And it's made an update to our list. And because it's always good to do something on stage for the first time, let's see if reverse to-dos actually works. And voila, it's reversed them while we were waiting. All right, let me switch back to the slides for a second. So type spec is one of the many ways you can build an MCP server. It's not the only way. We also have API Center. So if you've defined your API and it's already an API Center, you can use that to generate an MCP server. But type spec might be of interest to you if you're getting started on a new project, just to help you define your service overall, because of the many other things it can generate as well. But today, we showed you our type spec MCP server for generating MCP servers. The link to where you can get this MCP server is at the bottom of the slide. It will scaffold your MCP implementation. You can swap out to do for what you want to do for your own API. It'll generate what you need and build it for use with agents. So that's our first demo. Rang, I think it's now back to you for our second one.
Cool. All right. Now let's take the MCP server that Lori just built and turn that into a full AI agent. And I want to show, oh, actually, let me go through that slide real quick. So the tools we're going to use, the first one is an extension for VS Code called AI Toolkit, which really is a set of tools that helps you explore different models and create AI agents, either with local or remote models. And you can do all that entirely locally on your box. And second of all, of course, we're going to use MCP. All right, let's switch over to my machine. Is that showing? Oh, there we go. All right. This is probably the only time I'm going to be outside of VS Code, so I admit that. Because I want to show you the app I built that leverages this AI agent. So this is my personal task manager. And on the left-hand side, I have a list of to-dos on my list. I crossed out a few things, but the next thing on my list is to play tennis in the park, which is due tomorrow. And then one after is I have to move the demo backend side of the code into the container service app, which is a work-related thing. So the left side, pretty standard. I can add tasks, edit tasks, nothing fancy there. But what's more interesting is on the right-hand side, I have this AI-powered recommendation feature. And just to prove it's all real, you can see the date and time for real. So let me click that. A lot of things are happening as I click that button. So I have this front-end app, which is React, and I have a back-end Python Flask server, which is hosting my AI agent. And I have a remote model that is being used by that AI agent. And of course, I have 3 MCP servers that are at the disposal of that model. So the model decides which tool it needs to call and when to call it. And in the end, it's going to come back and give me a recommendation on the next task I should be working on based on the current time, the current weather, of where I'm at in Seattle, and this looks about right. It's actually sunny today, because I've been running this for days leading to this talk, and I'm always getting the recommended task to work on the demo backend thing. So today, the first time I can go and play tennis. But you can see this is real-time weather retrieval with current time. If we look at the factors, the model took into consideration this time. It says, oh, this suits as a morning time task. The current weather is sunny, so it suits outdoor activity. So model took all the responses from different MCP servers, synthesized that, and make a recommendation based on my to-do list. All right, without that, let's get back to VS Code. And I'll show you how I got there. So this is the AI Toolkit extension I mentioned. So install that in VS Code, and you will get access to a bunch of tools. So let's start with a model catalog. Because it's all about having choices, right? As a developer, we love choices. So we bring in all kinds of different models, all into VS Code. If we go through this list, there are models hosted on GitHub. And I love these GitHub hosted models because they are really easy to set up. Well, there's almost no setup. I'll show you in just a second. But second of all, it is all free for anyone to access as long as you have a GitHub ID. And signing with that, you have access to all these models. And there are new models being added almost every couple of days whenever they come out. So we already have a very long list of GitHub models here. But our choices don't stop there. What if I want to access local models? It could be because I'm working on an app that is for an edge device. I really want the model to be small and responsive. Or I'm concerned about data privacy. I don't want any of my information to leave my computer. Or it could be just because the cost concern, right? If everything runs locally, then I don't have to pay for AI tokens and stuff. So we have connected AI Toolkit with Ollama, which is a very popular framework for local model inferencing. If you have Ollama set up on your machine, you can bring in any of those models into the AI Toolkit, and then you can enjoy any of the features I'm about to show you in a bit. Microsoft also has trained our own models called Phi family of models that we call Onyx. Onyx is the runtime name. But essentially, these are models you can download and run entirely on your local box. If you have GPU, if you have NPU, you can totally leverage all those resources on your local machine or in the cloud to run these models. And last but not least, if you have an API key from a third-party model provider, OpenAI, Anthropic, or Google, you can bring that into VS Code as well. So if you add these models, it will ask you for an API key. But once you set that once, you can always access them all from within VS Code. So with that, I'm going to go the easiest route, which is to use a model hosted on GitHub. And really, it's just a single click to get into a pretty rich model playground that we have built. So on the right-hand side, these model instructions and settings, and we also support attachments as well as the ability to search the web. So it's a pretty rich playground. But why stop there? Because I want to be double productive. So I'm just going to bring in another model so I can look at both at the same time, side by side. So let me pick a reasoning model. I heard O3 is good. So now I have a side-by-side view. So what I want to do first is to test the model raw capability and see how it's capable of reading my to-do list and give me recommendations. Let's just say, what should I work on next based on the to-do list? And I'm going to hit send. And the request will be sent to both models at the same time. And then we can see GPT-4o is already responding with the recommendations. It's reading through my to-do list, which is basically just a JSON file with that list of my to-do. And O1 Mini is still thinking. It's a reasoning model. It's being very cautious, taking the time to think. But it's coming back with results, too. So what's cool about this is not only I can see how the responses are different between the models, I can also look at how many tokens they used. And if I can figure out the right place to zoom. Now, the resolution wouldn't let me do it. It's all right, I'm just going to have to, you have to squint really hard. On the left-hand side, 4o used 332 tokens. On the right-hand side, O3 Mini used 1,497 tokens for a very similar response. So this is one factor you probably want to take into consideration when deciding on a model, is the number of tokens it's used, because it's directly associated with the cost. And the other thing you might notice is the performance in how fast they respond with their answers. Reasoning models obviously is more capable, more thorough, but you wanted to evaluate and see which one is more suitable for your use case. I think for what I'm doing here, which is pretty simple, I think 4 is probably good enough. Obviously, the models are capable of reading my to-do list and giving me a recommendation based on due date and priority. But it doesn't really know where I am at the current weather and current time, so it couldn't take those into consideration. And that's when we can make the model smarter by giving it access to different tools. So let's do that. I'm going to select this model, which is 4o, and I'm going to head into this agent builder. Let me start a new one here. So to build an AI agent, really there are 3 things to consider. First of all is model, which we already decided we're going to use 4o. Second thing is instructions, also known as system prompts. You are telling the model what you want them to do. So that's the second thing. And third thing is the big box of tools, right? So we're going to get through those 3 things. So you can select a model here, which is already selected here. If you have set up, like I have so many models set up, local models, or remote models, or even models, these are models I have deployed on AI Foundry as model endpoints. So if you have those model endpoints, you can bring them into this AI toolkit as well. So here, it's really easy to switch between different models, so you can play with different models and see how they behave. And the second thing, like I said, is prompt. So we added this AI-powered prompt generation feature, because I just don't want to type in everything all by myself. I'm going to just do something very simple. I will say you are a helper assistant who can provide task recommendations by evaluating their priority, due dates, and current time and weather. And that's all I'm going to say. And I would let AI do the rest of the job. In a few seconds, it should come back with a system prompt filled in here. And as that's going, I can type in what I want to ask, which is, what should I work on Next, and I want to tell it that I am in Seattle right now, so it can look up for the weather for my location. All right, our system prompt is here. So the AI took my little prompt and turned that into a very comprehensive version with detailed steps to think through, to teach the model to think through, look at the input and filtering tasks, rank the tasks, and provide recommendations based on weather and time. It also defined the output format, which is nice. It actually had embedded a JSON blob here. But I'm going to show you how to bring your own JSON schema to structure your output in a bit. So I'm just going to take that piece out. And last but not least, it also came with a few examples to tell models how they should behave, and some notes. So that's pretty nice. I'm just going to leave it there. Though I should add a few things here at the top. Basically, this is saying that I'm telling the model you have access to 3 MCP servers. One is file system, which is an expanded version of what Laurie built. So this is more generic. This can access any files, not just to-dos. And the second one is weather. So I'm allowing the model to retrieve weather information in real time. And the third one is just to look up the current time. And I only recommend one ask at a time, and then I'm telling the model where my to-do list is. So with that, let's move on to the third component, which is tools. And that's where MCP servers come in. AI Toolkit supports adding your own existing MCP servers, as well as developing your MCP servers. For time's sake, I won't have time to run through how you create that, because Laurie already covered it. But I'm just going to show you how you can bring existing MCP servers to your agent. So in this case, I've configured these 3. So the first one is time. So the time MCP server has 2 tools. It gets the current time, and then it can also convert time to a different time zone. So I'm going to bring that in. And second one is file system. Well, there's a lot of tools accessible to the model. It can read file, can read multiple file, can write file, and all that. So I'm going to bring all that into my agent. And the last one is weather. So this MCP server is able to get real-time alerts, and I think it's a 5-day weather forecast based on your location. So with all that configured, we can simply hit run here and see what it does. So there's no deployment, nothing. Everything is running on your local box. And our tool is working hard to bring information back together. So if we scroll to the top, we can actually see, come back here. We can actually see what is happening when I hit run, right? So the model, first of all, is trying to decide which MCP server and which tool it should call to get the necessary information. So it has figured out, OK, I need to call this time MCP server to run this get current time tool to get time. And similarly, I need to get weather forecast. This is actually the location of Seattle. So it does that translation already. So it knows what to look for. And this is the tool response coming back. This is the current time. And this is the 5-day weather forecast. So you can see step by step what is happening with this agent. And if I scroll down here, this is the response coming back from that file system MCP server, which basically read my to-do list file, and that's everything here. Now, model took all those information and tried to make sense of everything, and came back with this final response that is finally saying playing tennis in the park. So that's awesome, but notice our output response is a plain text. In reality, you might want to structure it a little bit so your program can work better with it. So we do have this JSON schema output format feature in here. I have prepared a schema file, which I can show you. It's really, really simple. All I'm trying to do is to make sure the model response always contain these 5 things. Yeah, tell me where my location is, what the current weather is, weather temperature, the task it's recommending, as well as the reasoning behind it. So that's all it does. But if I were to run this again, now with the JSON schema, we are going to get a response that is a lot more structured. That will be a JSON object that we can then use in our program. OK, that is taking a little bit of time. It's very busy trying to find the right tools to call and make all those tool calls.
Needs more caffeine.
Yes, I know. It's too early in the morning. All right, it's coming back. All right, now we got a JSON object back. And we always love working with those in our apps with all the information we want. Oh, interesting. Now I have to go back to work on the demo again. And what is I don't know why. It's an indoor activity. Maybe it started raining outside. I don't know. Anyways, so that's kind of how you can iterate on your AI agent entirely locally in this tool. You can make changes to your prompt. You can try a different MCP tool. You can choose a different model. You can try all these different combinations with, we love choice and control, right? So we know exactly what we are getting. We can also test different user input. Obviously, I have hard-coded here saying that I am in Seattle. But I might want to make sure my agent can work with other different locations as well. So it's not cheating and always returns Seattle information. So if I do, let's see, if I do Miami, would I be able to play tennis? Let's see. All right. This time it's a lot faster. All right, coming back. Oh, there we go. Miami is totally sunny, and I can finally go outside. So you can keep testing that, but you probably don't want to do that manually, right? That's a lot of repetitive work. And what if we can turn that into a variable? Because we love variables in code. And as soon as I do that, variables section lights up, and I can put in value in here if I'm running this single run. But what if I can feed the entire data set into this variable? So it's not a manual process anymore. So if I switch over to the evaluation tab, and I am so lazy that I'm going to have AI generate some data for me. I don't even want to type in data manually. But what I want the AI to do is to generate these different locations and put everything into a dataset file. That would be my evaluation dataset. So for time's sake, I'm just going to say generate 3 rows. AI is smart enough. Our tool has analyzed my system prompt, analyzed the variables I have defined, and trying to figure out what it should generate. OK, so I just say do US cities only. That's only because the web MCP server I am using is getting information from National Weather Service, which only works for US cities. So it's not a limitation of the tool or AI or the model. So now we are using AI to generate a data set with random selections of different locations. So it's going to come back with a list. Oh, that's interesting. It's actually, this is funny, because I think I named the variable, which I should have done location. But you can see how adaptive our tool is. So actually what we try to do is it will try to give you a list of normal values, like New York City or Seattle, right? All these normal values where AI agents should work. It will also give you edge cases, like random strings, in a city that doesn't exist, and just to see how the AI agents can respond to different kinds of input. So with that, here you can actually go in there and then change things if you want. That's all supported. But what's cool about this tool, now I can simply hit run all, and have the tool go off and run through each row by row, make all those calls, tool calls, and come back with the JSON object. And I can look at them.
No tennis in New York?
No. The AI is very persistent, and that I should work on my demo. So I can see, all these responses. Imagine you have a much larger data set. You can just, let the tool run all this. You can come back and check the results. And of course, once we get the results, we want to see, decide how good they are. So evaluation is a key part of developing AI agents. And we enabled a local evaluation experience all here in VS Code. So there are two types of evaluations we have enabled. One is manual evaluation. We are all very familiar with the chat tools out there where you can thumbs up or thumbs down a response. So you can do so in here, your tool. So it's like your own annotation of the responses. You can save everything in your data set. You can always revisit later. But if you don't want to do that manually, imagine you have 10,000 lines. You don't want to do that line by line. Why don't we just dedicate that to the model as well? Because the model can be a judge, right? It's totally unbiased. It's going to give us a very fair judgment response. Not yet. But we do have many built-in evaluators for you to use. Some are based on code, some are based on prompts that you can select. Say if I want to decide on, if the agent actually completed a task I wanted to do, and I can select any model as the judge. Then I have this new column here added to my data set. Now all I have to do here is to switch to this Run with Evaluation button and click that. It will just go off and evaluate every single row and filling that column with a number that's between 1 to 5, 5 being the best. So you can kind of, at a glance, look at how well your agent is performing. And imagine, coming back with, if there's a new model comes out, you want to try how the model is behaving. Is it doing better or worse than my current model? You can pop back into the left-hand side, switch to a different model, kick off evaluation, and you can compare the results. OK, so last one before I switch back, I want to show you is, even though I showed you a lot of features in a UI component, but it's not about, doing magic using UI, because developers love to have control over what is happening and have clarity on what's happening. So you can actually get into code right here. We have different SDK selections. AI agent will be one of them. And this basically took everything I've defined in the UI and put that into a code snippet. Right? So of course, you could have just jumped in here and start coding with an SDK yourself. You can always do that. But with the UI, you can iterate so much faster without having to worry about the boilerplate code and still get to this code piece quickly. And from here, what I did was I took this file. And like Lori, I used the Copilot. I just feed that file to Copilot and say, based on this file, which I know my model works. I know my prompt is good. I know my MCP servers work. So I have control over that piece. But I let Copilot do the rest of the work and just wrap that up in a Flask server. And then it also created that front-end web app for me. And that was the demo app you saw. All right. Let's head back to slides. Thank you. Cool. All right, so we are very short on time, so I'm going to skip this. That was a tool you see. There's a download link there. Try it. Let us know what you think. All right, let's move on to the next demo. Sorry.
We're also going to have links to everything at the end.
Yeah, it's AI Toolkit, the full name, aka.ms. Go ahead.
All right. So now we're going to take our TypeScript MCP server that we ran locally and get it deployed to Azure. And to do that, we're going to use Azure Container Apps to help us get there. And we're still going to be running MCP to do this. So let me switch over to my laptop, which, there we go. So I've got a project in my workspace. We will give you the link to this GitHub repository at the end, so you can do it too. While I show you the code, I am going to AZD up this application. I've already warmed it up. It's been deployed once, so most of the infrastructure is created, but we're just going to get it all refreshed so everything works for this demo. So in our server.typescript file, this uses the standard MCP SDK for JavaScript to be able to do the server-sent events between our MCP server and any sort of agent that's connecting to it over MCP. And then our tools.typescript file is our tools for our to-do server. So our add to-do, list to-do, complete to-dos, that is all here in our file as well. This is leveraging the Azure Developer CLI, or AZD, to deploy this application to Azure. In this case, we haven't had to modify our MCP server at all to know that it's going to run on Azure. It's the same code, and we're just moving it from our local machine, where it was running locally, into Azure as a container in a container app, in a container environment. Our Azure.yaml is what's used by AZD to initialize and create our bicep infrastructure as code files for us, which is what's happening right now. So let me pop over to our mcp.json. This just redeployed. So I'm going to go ahead and restart my server and get a new chat session going with Copilot. And we can list to-dos. And this one doesn't come with any of the pre-recorded information that was in our last one. So we'll add a to-do to, let's say we're going to be create or deploy an AI model to Azure, because that's what Rong's going to show next. And now we can list to-dos, and that should be there. So we're using the same GitHub Copilot client in agent mode to talk to our MCP server in the cloud. So we have our, you can see it's an SSE remote server, and it's got all of our tools available. So I'm not going to add more tools this time. We just showed moving now our server to the cloud. And eventually, we're going to have our agent in the cloud as well to talk to it. So swapping back to the slides. If you aren't familiar with Azure Container Apps, it is a serverless container compute platform that helps you build cloud-native apps. It extracts away the complexities. You don't have to understand Docker or containers because it's taking care of all that for you. It's purpose-built, event-driven. It helps you scale and can even scale to 0 if nothing's running, and offers a pay-per-second billing model. So I encourage you to check that out. And if you aren't already using AZD, please check out the Azure Developer CLI as well. It's a higher-level, developer-friendly way of helping you get apps onto Azure without having to become a bicep expert yourself. And because it is creating those infrastructure as code files, it's something you can hand off to your platform engineering team later when you're ready to start moving into final test and going to production. We've got tons of templates available to help you get started, so please check it out. And then if you would like access to this MCP container app building block, it is available as a sample in Azure Samples on GitHub. It contains everything you need to get going. I will warn you that this particular container is unsecured in Azure because we are accessing it from GitHub Copilot agent mode on the desktop. When we move everything into Azure, I'm going to show you how we're securing that to make sure it's, you don't have any nefarious actors getting into your MCP server. All right, now Rong, back to you.
All right. Yeah, finally, we are going to move the model and agent into AI Foundry. So AI Foundry is a unified platform and very secure to develop and manage AI agents and applications at enterprise scale. So we're going to look at how we're going to work with that service from within VS Code by using the Foundry extension. All right, so let's move over to my machine. There you go. Oh, there we go. All right, so this is an extension I was referring to. Simply search for Azure AI Foundry, that's all. And once we have that installed, on the left-hand side, there's a side panel that gives you access directly to models you have deployed, agents you have deployed in the service. Since our goal is to get the GPT-4o model we used earlier locally into Foundry, we're going to look at the catalog. This, again, has a long list of models that's already available in the Foundry service. So we're going to let's do a quick search and say I want a 4o model, which is right here. And all I have to do is to hit that button that says Deploy to Azure. And select my AI service. I want the latest model and going to global standard region. And I'm just going to keep that name. Yes, it's going to incur cost. Yes. And done. Yeah, 2 seconds, right? That's done. All right, so now I can come back here to this resource tree and look at the model we just deployed. And here it is. It's GPT-4. And I can click on it and look at the details. This should be very familiar to you if you have seen the Foundry portal, and that's exactly the same information. And one thing I might want to do is, because I'm going to build an AI agent using this model, and I might want to adjust the rate limit, because the rate limit by default is pretty low. And you might think, now you have to leave VS Code. But no, I'm not. My favorite feature here, you can edit. And you can see this rate limit here. I'm just going to drag it all the way. For demo purposes, don't do that in your own production environment. But I can save it and done, right? Not even VS Code. And now I'm going to create an agent. Let's just do to-do agent and save that. All right. OK, so we have a YAML file on the left and a very simple designer on the right. So who loves editing YAML files? No? No? I thought so. All right, but we're going to do that here. But this is not a normal YAML file. This is an agent YAML because we have built IntelliSense in here, if it will load. Oh, wait, it's ID colon. All right, I might have to reload VS Code because token expires sometime. All right, let's try it again. So the idea here is this YAML IntelliSense we built, especially for this agent service, and it has knowledge of your current Azure subscription, your Azure project. So it knows what models you have, and we offer that through IntelliSense. All right, let's try again. See if we have better luck. No.
It's ready for lunch, huh?
I know. Nope. All right, so instead, we're just going to do GPT-4o. Maybe we'll come back. But yeah, imagine this shows IntelliSense with autocomplete list of the 2 models I have available in my subscription, in my project. And here I'm going to define instructions. Basically, I'm just going to take everything we defined earlier in the local model agent and then put in here. Oops, what did I? Here. And that's being synced over to the left-hand side for. All right, the only thing I need to check is this file path, because now I have moved my to-do.json file into the vector store in Azure, so it's no longer a local file. That's all I'm fixing. And that's all. And finally, we get to the tool section in here. This is, again, where you can expand model capabilities by connecting to external tools. And you might have seen demos in different places where in the portal you can connect to these different tools, and you can do the same in VS Code. And I'm going to see if my sweet IntelliSense is back. It is.
Yay.
Yes. Oh, my gosh. All right. So even if we're editing YAML, there's great help at your fingertips. So at the top of the list, you see these are 4 built-in tools for the agent. Now, we can go ahead and select the first one, which is beam grounding, right? Remember in my local agent, I called weather service to get real-time weather. So in here, instead of using that MCP server, I'm going to use Bing search to ground that weather information. So because Bing can do search for whatever information I want. So I just need that one. And I've added it here. And what's neat about my IntelliSense is it knows my subscription. It goes and searches for the Bing grounding connections I have in my subscription. All I have to do is to tab. And the second thing I want to add is file search, because my to-do list, the JSON file, is in the vector store. I wanted the model to be able to access that file. And again, IntelliSense to the help. It knows the vector store I have in my subscription, and just tab. And that's all I need to do. And now I can hit the button to create that agent. It's done. 2 seconds, 1 second. All right, come back here. Now I can look at my agent. And I forgot what I named it out to do. There we go. And here's the agent that's deployed. And I can start playing with it by opening our playground in VS Code. And I'm just going to ask the same question. What should I work on next based on current time and weather?
Fingers crossed for tennis.
I'm not sure. I'm in Seattle. All right. Let's see what happens. Now we are actually hitting the agent service endpoint. This is no longer local. This is all running in the agent service, which is a managed service by AI Foundry. And then I can actually look at what is happening on the service side. So the model is calling 2 tools, right? Because I gave it access to different tools. No, still the demo. Even though we just finished that.
You're almost done.
No. Yeah, so it called file search to look at my file. It called Bing search to get my weather information in Seattle. And again, the model synthesized and give me back the final result. One more thing before I switch off, which is to look at, you can actually look at more information about that interaction we are having with the agent, because we love looking into the black box, right? We don't want mysteries. We don't want magic. So in here, we can actually access the latest thread, which was the interaction I just had with the agent. Down here, you can expand step details and look at every single step that agent tool, the agent service is performing on the service side. So the first one being file search, and it find my to-do list .json file in the vector store. So you can follow the trace and look at what happened on the service side. All right, with that, let's go back. I'm gonna skip through these real quick. You have seen this like 50 times, right? So let's just move on.
All right. So now we're at the finale, and we want to make sure everyone feels loved. So we've shown you TypeScript in our MCP server. Her first local agent was in Python. Now we're going to switch to .NET for our agent in the cloud. And so let's move over and show you how that's done. And I'm going to start AZD up so that can get going while we're talking. So Microsoft works with both OpenAI and Anthropic to contribute to the official .NET implementations of the OpenAI library, as well as the MCP SDK. And so in our client program, we're leveraging both to go ahead and get started. And we also have an extension for OpenAI, an Azure extension, that helps us build a secure deployment in Azure. So you can see as we go down, we're leveraging the inference endpoint. And if you swap out models, like Rong was talking about, any OpenAI compatible model will work with this code. And then we're also leveraging the MCP SDK for SSE as well. If we look at our bicep while things are deploying, we are doing this securely. We are creating app identity so that the two can talk to each other. And while it's deploying, I'm going to show you one thing in the portal. We don't have to do anything. I'm just showing it to you. So in this case, our server and our client are deployed in the same ACA container app environment. And we're limiting traffic to be to things within that container environment. So nothing else can get in versus the MCP server we deployed the first time, so we could use it from GitHub Copilot, accepted traffic from everywhere. So we've secured it in this particular instance. Let's see if we are back up and it's still going, still going, still going. So it's deploying redeploying our server so it's secure and deploying the client, and should be up in just a few seconds. One of the other things that we're doing is we are using Entra ID as part of that to help secure ACA, the container registry, and make sure all communications are secure. The way we've set it up, the first time you deploy, you launch the client, it will ask you if you are willing to accept the permissions to connect to it. It won't do that again this time because I've already deployed it several times. Trying to think what else I need to tell you. If you weren't in the same container environment, so for example, if your server and client were in different environments, they're developed by different people, you can use APIM to secure the key to connect the two together. So we're not doing that in this case because we're all in the same container environment. And we're almost there, almost there. Waiting, waiting, waiting. I can only make it scroll so fast.
Oh, it's doing things.
The server, what?
It's doing things.
It is doing things.
That's
It is
good.
working hard on our behalf. We are thankful we have AZD to do this for us, rather than having to individually create all the resources, configure them, make sure they're all connected up together. We are very happy AZD is taking. All right, we are deployed. Success. So I will go back to my client and reload it now that we're deployed. And I'm going to list to-dos, and it should come back blank because there's nothing in this and fully reload. There we go. Oh, see, I've made it mad by trying to rush it. It says it was happy. Let's try one more time. Did my URL change? Nope, still FB277. See, it's mad. It doesn't want us to leave. It wants us to stay longer and try and troubleshoot things. It doesn't know we have a deadline. Pardon? Did the URL change on me?
Oh, this has internal.
They both have internal.
Is that what happened?
Huh. Thank you, but that is not the mystery. Let's go see if the URL for my client changed. We will go back here. I think this is the one we're using, client app.
Right. No internal.
Well, the server and client are under different URLs. And so VS Code is showing us this is the server app URL, which needs to go in the mcp.json, which we have. I can see if pasting it again makes it happy.
Yeah. Oh, wait, I'm wondering that.
Okay.
Okay, one last try.
One last try.
Fingers crossed.
And it did not. So I was going to be very prescriptive with what I added to the to-do list this time and tell it to add a 10 build celebration, because I don't care what the weather is. I'm going to the build
going to
celebration
the
tonight,
party.
and I hope to see you all there. All right. So I think this is the slide you want to see. This is where you can find all the resources, the source code we used today, our GitHub repo that contains links to everything, and all of the related sessions. Thank you for joining us today, and we'll be happy to answer questions off stage.
Yeah, thank you so much.